Question 8. Normally distributed. Normally distributed. That means I want to use Z tables. Brilliant. So top 10% of students. Top 10% means that you've beaten 90% of people. Okay, we can look that up, and that'll give us a Z score. So 90% is going to be between here and here. I think this one's closer. It's only 3 away, whereas this one's 15 away. So this is, you can't see the very end, but it's 1.2. 1.28 is what we're going to do. So Z is 1.28. You put this into this formula. Now, why this formula and not the one with root n at the bottom? This is not a sample. So there's no sample there. It's not said, oh, we picked 100 runners or we picked 500 runners. It's not a survey. It's just, it's one race. So, or one exam. So you got your Z score. Brilliant. We have our mean, 176. We have standard deviation. We've just got to solve this now to work out x. So move the 36 up and multiply. Add on the 176. You get 222.08. So that's the lowest you can score to be in the top 10%. Now, you want an actual mark in an exam, so you've got to pick whether 222 is enough or 223 is enough. Because you need 222 and a little bit, 222 is just short. So you need to go up to 223. Right. So this one is achieved between two different marks. Okay, so this is a bit of an interval. So first thing we're going to do is we'll set up two z-score equations. So the equation that we used above, and we get two values of z. So this one we can just look up, and you'll get your probability. And this one as well. This is a bit of a problem though. You can't look this one up because it's a minus. So if you look at the z-score tables, they're all. It starts from Starts from 0 and goes upwards. So if we want to find 0.944, we can do that 0.94. So we're going to use this percentage, this probability, but we can't look up minus 0.3. We can look up positive 0.3 though and use the fact that the graph's symmetrical. So that's what we'll do. So 0.94 is here. We work out that value is 82.64%. We saw that before. That's everything below this point here. Now, we don't want everything below this point because we don't want this white bit. We want the interval. So we don't want to include this white bit. So if we can work out what the white bit is and subtract it, then we'll have our answer. So the 82% is really useful. So that's that. We just want to take away this white bit. Now, how do we do that? Well, we just look this up and we can take it away from there. Again though, we can't look this up because it's minus. So if I come down here, it's a little bit faint, I suppose, but you could look up 0.31 and it gives this big white bit here. Again, it always goes to the left. We don't want that. We want the bit on the right. So we're going to get this percentage and then we're going to take it from 100. We're going to do 1 minus the decimal that it gives. So we're going to do this. Okay, so we look up 0.31. We do 1 minus that answer from the table that we look up. You get 37.83%, and then you subtract them. And by subtracting them, you're just taking this white bit away from this shaded bit. So 44.81%. Okay. Right. This is a survey. So 60 students. Okay. So it's going to be the root n at the bottom. Okay, so same sort of equation. Instead of using this z-score, we're going to use this z-score. Okay, now this is quite useful, the reject minus 1.96 and 1.96, but we'll come to that in a minute. So we're going to find the z-score. So nice and easy. We're just going to put numbers into the equation and we get this. Now, if we were trying to do a test here or trying to do a hypothesis test and say, right, they used to do 21 hours, but now they're doing 19.8. Has this actually changed? Or have you just picked 60 students that don't study very much? Like, has it actually changed? Well, minus 1.78 is, if this is minus 1.96, and this is 1.96. Minus 1.78 is just about inside this region. And if it's inside, then you're fairly close to what your average is. So you're fairly close to 21 hours. So by being close to it, this isn't significant. So you wouldn't be able to make any claims like, oh, it's changed or whatever. So just bear that in mind for the next question. It has nothing to do with this question. It's just a little bit of learning, but this is the answer, and we can stop there. Right, last little bit for this part. We've got to find a p-value of the test statistic. So the p-value, you take your z-score, you look it up. Now we can't look this one up because it's minus, we're just going to look up the plus, which is this guy. And then we do 1 minus that, always 1 minus that for the p-value. You get this answer here, double it, and that's your p-value. And that process is always the same. Okay, so get your z-score, look it up in your tables, get your percentage, 1 minus your percentage, double it, and you're done. Now, for this one, we can make conclusions as well, just like we could from the 1.96. But for this one, we're comparing it to 5%. So let's just have a little look. Now, if you're far away from the average, then you would be in this side or you would be in this side, which is 5%. That's how it's set up. So if you're in the outside 5%, you're far away enough from here to be able to say, well, it's changed. It's no longer the 21 hours what it was at the top. It's now different. Okay. Now, because this 7% is bigger than 5%, what that means is you've actually come in further than the 5%. So it means you're actually closer to the mean than you would have to be able to say, okay, we're going to reject. Okay. So yeah, the news report said that the study was different, or the study was 21 hours. We can say that, okay, we can't disprove that. Even though we found it was 19.8, we can't say that you're wrong, because 19.8 is close enough to 21. And that's also true with the 1.96 thing.